Yeah, hello guys. This video is about the common ion effect. Yes, so let's dive in. I've already written some short notes here that will help you. If you read from the first line, the common ion effect, it refers to decrease in the solubility of an ionic compound when a common ion is added to the solution from another source. Yes, so that's the common ion effect. For example, let me give you a general example before I use the ones I've written already. Let's say you have a compound AB, then let's just say this is an aqueous solution. Then decomposes into, or it dissociates into A plus and B plus ions, right? So let's assume this is aqueous. This is aqueous. So what I'm trying to say about the above definition, trying to define the common ion effect, is simply to say the common ion effect, you see, is the decrease in the solubility of an ionic compound, right? Why do I say it's the decrease? It's the decrease because when we add a common ion to the solution from another source, it has a certain effect. And then that effect, since that ion is already common, that means it's already present. So that is to say, what am I saying? You see, if I were to add another compound into the same solution where this is present, and that compound happens to have maybe, let me use a green marker, maybe the same ion as A plus, you see that this becomes a common ion. Why? Because it was already present in the solution from this first compound. But then the common ion effect is such that when you add another common ion, it has to be from another source. You understand? So, but then we are trying to talk about the effect of adding another compound into an already existing solution that has the same ion. So we are saying it's common ion because the ions are present. The ion is common, it's present in both compounds. So, but then what is the effect of adding a common ion? That's the mandate of this video, like the common ion effect. Now, maybe back to my short notes. Now, for example, I was trying to just explain the definition there. Example one. If you look at example one, you have maybe you have the acetic acid and the HCl. You have a solution that you can have a solution where you are mixing the acetic acid and the HCl. But then what happens in the solution? Let's consider equation 1, this one, and equation 2. You see, if you try and let's try and identify our common ion. Our common ion is this ion. Why? Because it is all present here and here. So it is the common ion. You understand? So what happens to the common ion effect? For example, you will start, let's say maybe you will begin with this in your solution, with acetic acid, and then it ionizes into the acetic ion and hydronium ion. Now, if you bring the concept of the common ion effect, it means you have to add the common ion from another source. And what is our source this time? Our source is HCl. So that's why in my definition I say it refers to the decrease in the solubility of an ionic compound. When a common ion is added to the solution from another source, that's the common ion effect. Now I will shortly talk about the decrease in the solubility of an ionic compound. And also these are Le Chatelier's. So what happens in this solution if you add this source, HCl as the source, that comes with another ion, the H3O plus ion, right? So what happens? You can see that this at equilibrium here, what will happen at equilibrium? Where will the equilibrium shift? Okay, let's talk about something here. I've written here. Ionization of HCl will affect the equilibrium position of fraction 1. That means the ionization of this HCl, it will have an effect on the position of equilibrium on the first equation here. And similarly, the ionization of the acetic acid, this one, it will have an effect on reaction 2. Those are the points that I've written here. They are very key points in this topic. But then, okay, what will happen here? Like when I add this, it's simple. You have to notice something here. You see, HCl is a strong acid, and then acetic acid is a weak acid. So that means the ionization of this acetic acid will be suppressed because it partially dissociates. But then this strong acid HCl, it will dissociates almost completely, maybe 98%, 99%. So the ionization effect of this acetic acid will be suppressed. And what does that mean to the equilibrium? It only means the HCl will be the one to shift the equilibrium position on reaction 1 instead of what? The acetic acid to shift the equilibrium position of the second reaction. So that's the thing. We have to notice even in bases. This applies both in bases and in acids. So the HCl will suppress, the ionization of HCl will suppress the ionization of the acetic acid because it's a weak acid. Now, what I want us to look at is how questions are asked maybe in your exam. So let's dive into example number 2. Yes, you have the sodium acetate, and then it dissociates into the acetate ion and sodium ion. So now, and then we bring another source, right, which is acetic acid here, right, and then it dissociates into what? It dissociates into same acetate ion. So what is our common ion? Our common ion is the acetate ion. So now, where will the equilibrium shift from here? Where will the equilibrium shift from here? Now, it's simple. The equilibrium will shift to the left, right? Why will the equilibrium shift to the left here? Because it's simple. Because the ionization of this guy is suppressed. Why is it suppressed? Reason number 1, this guy is a weak acid, this guy is a strong acid. So it means the ionization of this sodium acetate here, it will suppress the ionization of this. That means it will favor what? It will favor this reactant. Hence the equilibrium shifting to the left. I hope that makes sense. I've answered your question from here. Now, let's look at example number 2. By the way, if you have any questions, you can drop them. Now, you have ammonium chloride dissociating to this ammonium ion and this chlorine atom. So, and then you have the second equation. You have ammonia dissociating water, and it gives you this and this. So what's the common ion? Is this one. So what will happen here? Where will the equilibrium shift? Now, this is simple. How is it simple? Look at this. You see? Okay, I will apply Lich now. Maybe the one that we see that this is a weak acid, it partially dissociates, maybe it confuses you. But then think about it. Lich says more concentration. If you have more concentrated products, that means that will favor your what? It will favor your reactants. Now, you have this ion already present into the solution, and then you bring in another source which already has the NH4+. So what will happen here? That means you'll be having more concentrated products of NH4+, and this is a reversible reaction. So what will happen to the equilibrium? It simply means more concentration on the right, hence the equilibrium will shift to the left. That's another reason why this equilibrium will go to the left. That's why I say the common ion effect, it simply affirms Lich Antilius. So I think the common ion effect is a very simple concept to get, and hardly do they ask questions. You will see them on multiple choice. So I'll urge you to practice more. If you have any question pertaining this lecture, please talk to me. You have my number. So I will simply maybe drop some questions that you should do. Yeah, let me give you maybe some questions. I'll drop some questions on WhatsApp right now concerning these topics before I move on.